Artificial intelligence infrastructure does not live in a vacuum. It has to exist within the complex ecosystem of enterprise IT systems that organizations have spent decades building. Companies already have massive investments in ERP and CRM platforms, in security systems, in data warehouses, and in operational monitoring. If AI is introduced as a standalone island, it will struggle to gain adoption, generate resistance from IT teams, and ultimately fail to scale. The true goal is seamless interoperation. AI must connect into existing workflows, respecting the compliance obligations enterprises face, and enabling adoption without disruption. When integration is done well, the friction that slows adoption is reduced, and the return on investment climbs dramatically. The real measure of AI success in the enterprise is not how powerful the models are, but how well they integrate with the systems already running the business. The importance of integration starts with the reality that enterprises have already poured billions into IT systems. ERP platforms handle core financial and supply chain processes. CRM systems are the lifeblood of customer relationships. Data warehouses serve as the backbone for analytics and decision making. Security infrastructures guard sensitive data, monitor access, and ensure compliance. For AI to succeed, it must plug into these systems, not attempt to replace them. AI should make ERP smarter by optimizing forecasts, enrich CRM by improving engagement predictions, and complement security by enhancing anomaly detection. The less disruptive the integration, the faster adoption will happen. Enterprises are not looking to rip and replace. They want AI that augments what they already have, creating new value on top of existing investments. When we map out the systems AI needs to connect to, the scope becomes clear. At the data layer, this means SQL warehouses, Hadoop clusters, Snowflake environments, and Databricks platforms. At the application layer, AI must work with SAP for enterprise processes, Salesforce for customer engagement, Workday for HR, and ServiceNow for IT workflows. Identity and security integrations are essential, plugging into Active Directory, LDAP, and single sign on providers. On the monitoring side, tools like Splunk, Datadog, and ServiceNow ITSM must have visibility into AI systems. And of course, networking and cloud systems such as firewalls, VPNs, and SD WAN must securely accommodate AI traffic. AI is not a separate system, it is an overlay that must weave itself into every corner of this landscape. As straightforward as this sounds, integration comes with significant challenges. Legacy constraints are the first hurdle. Many enterprise systems were built long before modern AI workflows existed. Their APIs may be limited, outdated, or non existent, forcing creative workarounds. Data complexity adds another layer. Different formats, schemas, and governance rules across systems make it hard to build clean, unified pipelines. Performance can also suffer when trying to connect batch oriented systems with AI models that demand real time inputs and outputs. Finally, there is the human element. IT and security teams are often cautious, and they may resist projects that appear to bypass established protocols. Integration, then, is not just technical, it is organizational and cultural, requiring careful alignment and communication to succeed. At the heart of AI integration is the data integration layer. For AI pipelines to have value, they must connect directly to enterprise data warehouses, and these connections must be bidirectional. AI needs to consume historical data for training, but it also needs to push outputs, predictions, forecasts, classifications back into the warehouse for reporting and action. Compatibility with existing ETL and ELT standards is non negotiable. Access must be governed by strict role based controls, with every interaction logged for audit. For example, features used in training might be sourced from Snowflake and then loaded into an AI feature store, creating a loop of intelligence that is secure, compliant, and traceable. Identity integration is one of the most sensitive areas because access to AI systems often equates to access to sensitive data. Enterprises already use identity providers such as Active Directory, Okta, or Ping, and AI platforms must integrate with them rather than creating parallel identity systems. Multi factor authentication and single sign on are baseline requirements. Role mapping is also essential. Roles within the enterprise must map cleanly to roles within the AI infrastructure. A data scientist should have the right to build and test models. An infrastructure admin should manage the underlying systems, and auditors should have visibility into logs without elevated privileges. This mapping ensures accountability and aligns AI with existing security governance. One of the most dangerous pitfalls is when AI infrastructure becomes a blind spot in enterprise monitoring. To prevent this, AI logs and metrics must be exported to the existing monitoring stack. Whether the enterprise uses Splunk, Datadog, ELK, or ServiceNow, AI systems need to be visible in those dashboards. Network operations centers and security operations centers must see AI workloads as part of the unified environment. Incident response playbooks must align AI issues with existing IT processes. When this visibility is in place, mean time to resolution for AI-related problems drops significantly, and AI stops being a silo and becomes part of the enterprise nervous system. Networking is another critical integration layer. AI systems may run in the cloud, on premises, or both. They must connect securely to existing environments, often through VPNs, Direct Connect, or Express Route links. Security standards such as enterprise firewall rules, data loss prevention policies, and encryption standards must be enforced consistently across AI traffic. APIs require governance, with secure gateways enforcing authentication, rate limits, and monitoring. This ensures that AI workloads are not a backdoor around enterprise security controls. Networking and security integration transforms AI from an isolated experiment into a fully trusted component of enterprise IT. True business value comes when AI is embedded directly into enterprise applications. This is the layer where employees feel the impact. In Salesforce, AI driven lead scoring can help sales teams prioritize opportunities. In SAP ERP, AI can improve demand forecasting and optimize inventory levels. In ServiceNow, AI can triage incidents and recommend resolutions, speeding up IT support. These integrations are not abstract. They deliver tangible improvements to workflows employees already understand. When AI is seamlessly embedded, adoption skyrockets because the benefits are immediate, practical, and aligned with daily operations. Enterprises have a variety of tools to smooth the integration process. Middleware platforms such as MuleSoft, Boomi, or Talend help bridge AI with legacy systems. Event streaming platforms like Kafka or Pulsar allow real-time data to flow into AI models. API management platforms such as Apigee, Kong, or Azure API Management enforce consistent policies and provide observability. ML-specific integrations, like combining MLflow with CI/CD pipelines, bring machine learning directly into the enterprise DevOps ecosystem. These tools reduce friction, accelerate adoption, and ensure AI integration does not reinvent the wheel, but builds on proven enterprise practices. Consider a financial services enterprise with a complex stack that included Oracle databases, SAP ERP, and ServiceNow ITSM. The organization needed AI for fraud detection but could not afford disruption. The solution was integration first. Fraud detection was deployed through Kafka event streams feeding into AI models. Monitoring was connected to existing Splunk dashboards, ensuring full visibility for operations teams. Role-based access controls were mapped directly to Active Directory groups, ensuring security consistency. The results were impressive. Fraud detection became 72% faster, uptime reached 99.9%, and all of it was achieved while maintaining compliance with financial regulations. The lesson is clear. Seamless integration enables measurable gains without compromising governance. A manufacturing company faced a different challenge: legacy manufacturing execution systems with limited connectivity. To integrate AI for predictive maintenance, the team built custom APIs bridging old MES platforms with modern AI pipelines. The system connected on-premises SCADA environments with Azure cloud resources in a hybrid architecture. This balance satisfied compliance requirements while still achieving low latency performance. The outcomes were significant: a 37% reduction in unplanned downtime and annual savings of $4.2 million in maintenance costs. The takeaway is that even industries with entrenched legacy systems can capture AI's value when integration is tackled thoughtfully. Zooming out, AI should be thought of as part of the enterprise nervous system. At the center sits the Enterprise AI Platform, a hub that integrates with all systems. ERP systems feed transactions and operational signals. CRM systems supply customer insights and feedback loops. Data warehouses exchange information in both directions, enriching analytics and feeding model training. Monitoring tools collect telemetry and performance data, enabling continuous improvement. The message is simple: AI must not live on the edge of the enterprise. It must be woven into its fabric. This is what makes AI adoption sustainable and scalable. To conclude, the hallmarks of successful enterprise AI integration are clear. Comprehensive integration means AI must connect with data systems, identity systems, monitoring tools, applications, and networks. Addressing challenges like legacy systems, governance requirements, latency constraints, and compliance is essential. Leveraging enterprise-grade tools, middleware, event streaming, and API management smooths the process. And the true success criteria lie in weaving AI seamlessly into the IT fabric, enhancing existing systems rather than competing with them. Integration is not the enemy of innovation. It is the enabler that allows AI to move from the lab into the heart of the enterprise, delivering both value and trust at scale.